What type of effort attempts to bring all of an organization's cloud activities under more centralized control? Cloud access service broker, cloud orchestration, cloud governance, or cloud migration. Cloud governance is essentially a set of rules, processes, and tools that guide how your organization interacts with the cloud. It is like having a rule book for your cloud activities, ensuring everything is done efficiently, securely, and in compliance with regulations. The cloud is flexible and scalable, but that can also lead to sprawl and inconsistency. Governance or cloud governance helps maintain control and organization even with various cloud services and users. Cloud governance sets security best practices, access controls, and data measures. This helps prevent unauthorized access, data breaches, and other security threats. By optimizing resource allocation and preventing unnecessary services or configurations, cloud governance can help you save money on your cloud bill. Many industries have regulations regarding data privacy and security. Cloud governance helps ensure your cloud activities comply with these regulations. Now, how does cloud governance directly impact cybersecurity? Cloud governance defines secure baselines for cloud deployments, ensuring systems are set up with security in mind from the start. Cloud governance dictates who can access cloud resources and at what level of access they have. This approach minimizes the risk of unauthorized activity. Cloud governance sets guidelines for data encryption, storage, and access, essentially safeguarding sensitive information in the cloud. Governance processes often involve security training for users, keeping them informed about best practices and potential threats. AWS, as Amazon Web Services, provides 4 related services that enable you to set up your organization for success with cloud governance. AWS Organizations. This service acts as the foundation for your cloud governance strategy. It creates a hierarchy within your AWS accounts, allowing you to group them for centralized management, billing, and access control. In the hierarchy of these services, AWS Organizations comes first as it establishes the core structure for your cloud environment. AWS Control Tower. This service builds on top of AWS Organizations by providing a comprehensive governance framework. It automates guardrails and best practices around provisioning, access control, compliance, and cost optimization. Control Tower uses organizations as the underlying structure to enforce governance rules across your accounts. AWS Config is a service that continuously monitors and records your AWS resource configurations. It helps to ensure your resources are set up according to your governance standards and detects any deviations. AWS Control Tower can leverage AWS Config to continuously evaluate your environment against your guardrails. AWS Audit Manager is a service that assists with automating audits and compliance assessments. It allows you to define audit procedures, to collect evidence, and analyze findings to ensure adherence to your security and compliance requirements. Audit Manager can be used to assess the effectiveness of your overall cloud governance posture, including the configuration settings captured by AWS Config and the guardrails enforced by Control Tower. This AWS account, in which I have deployed AWS Control Tower, is referred to as the management account. I have 3 organizational units. Now, excluding the root organizational unit, I have a sandbox organizational unit, a security organizational unit, and a labs organizational unit. Directly nested in the root organizational unit are the 3 organizational units of sandbox, security, and labs. Within the root organizational unit is my management account, which is this current account I am using. In the Sandbox organizational unit, I have two other accounts. These are the accounts I will use to experiment with cloud governance controls provided by AWS Control Tower. As of this edition, AWS Control Tower provides you with over 513 controls to support the distinct security requirements of all your workloads. Imagine this scenario. My company is developing a new cloud native payments application that requires the use of Amazon Simple Storage Service or S3 to store application logs that may contain sensitive cardholder data. In order to help ensure compliance with Payment Card Industry Data Security Standard or PCI DSS, I will leverage AWS Control Tower's comprehensive controls management capabilities. I will enable a series of controls on my Sandbox organizational unit to help ensure that developers who use the S3 service will remain in compliance with certain directives from PCI DSS. The first directive is to ensure that log file integrity is maintained. This is a requirement of PCI DSS 10.5.5. The second directive is to make all authentication information unreadable using secure socket layer when applications make requests to S3. The third directive ensures that developers are prevented from modifying the level of encryption on the S3 buckets. This would prevent developers from creating S3 buckets capable of storing data in an unencrypted state while at rest. A control is a high-level rule that provides ongoing governance for your overall AWS environment. Controls are expressed in plain language and enable you to express your policy intentions. For example, if you enable the detective control, detect whether public write access to Amazon S3 buckets is allowed on an organizational unit, you can determine whether a user would be permitted to have read access to any S3 buckets for any organizational unit. AWS Control Tower provides three control behaviors. Detective controls detect non-compliant resources in your accounts and provide alerts through the Control Tower dashboard. These are implemented using AWS config rules. Proactive controls check compliance of your resources before they are provisioned, and they are implemented using CloudFormation hooks and guard rules. Preventive controls prevent actions from occurring and are implemented as service control policies attached to your organizational units. Each control is identified by a unique identifier and an easy to understand objective. Each control is also categorized across multiple dimensions like behavior and guidance. The control description provides a concise summary of the control behavior. Controls are implemented using one or more artifacts like AWS Cloud Formation Guard rules or service control policies. You can view these artifacts to understand exactly how the control will be deployed. At this stage of the lab, I will enable a detective control that will detect and alert me about S3 buckets that do not have versioning enabled. Using versioning, you can preserve, retrieve, and restore every version of every object stored in your S3 buckets. This ensures that existing log data cannot be changed without generating an alert. To enable this control, I'll click on Enable Control. I would select the organizational unit, which is my Sandbox organizational unit, and enable control on this organizational unit. So after a few minutes, the control state on the organizational unit Sandbox indicates enable. Now remember, I have configured these only on my management account. Now I go to Sandbox organizational unit, and within a few minutes, it's going to tell me if I have any non-compliant resources. So currently I'm my Sandbox account, and notice the description that tells me the purpose of the stack. This is the stack that was deployed by the AWS Control Tower that is running in my management account. The description of the AWS config rule matches what we expect from the detective control. Now what I'm going to do is create an S3 bucket that isn't enabled for versioning. So I'll create an S3 bucket. I'll call this Cloud Brewery versioning. I'll leave everything the same and disable bucket versioning. Now after a few minutes, I expect to see one non-compliant resource. So after a few minutes, it tells us, or it tells me at least, that I have one non-compliant resource, and it identifies the resource which is my Cloud Brewery versioning S3 bucket. Now I'm checking this from the Cloud Brewery sandbox account. I can also verify non-compliance from the Control Tower or management account. So I'm going to switch to that. I'm going to filter the control, and after a few minutes I will see the non-compliance notification. So currently it tells me that my sandbox account or the sandbox organizational unit is in non-compliant state. We just need to investigate which is the non-compliant resource, which again is indicated as the S3 bucket, and it also tells me which control it is not compliant to. So I'm going to go back into the S3 bucket and enable versioning. So I'll switch to the control to the sandbox account. I am back in my sandbox account. I'm going to go to the S3 bucket. So I'll browse to S3 and go on the bucket, click on properties, edit bucket versioning. And after a few minutes, I will get a compliant resource. So after a few minutes, it tells me I have 0 non-compliant resources. Let me confirm what this rule is. So yes, it tells me I have a compliant account. And if I check the rules, I have no non-compliant rule. This is just one simple scenario of how cloud governance can or should be implemented in your AWS environment. For the sake of time and scope, I won't be implementing the remaining 2 scenarios, which should be straightforward anyway once you have AWS Control Tower and AWS organizations set up. Now, overall, cloud governance provides a framework for secure and efficient cloud adoption. It helps you or helps your organization leverage the cloud's benefits while mitigating risks and maintaining control over your cloud environment.